Hey everybody, welcome to Chapter 5, Section 1, Bisectors of Angles and Triangles. At the top of these notes, I have some definitions to go over. It says, recall that a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. If a bisector is also perpendicular to the segment, it is called a perpendicular bisector. Okay, so segment bisector, this just cuts in half AB. So perpendicular bisector cuts in half and then it creates a right angle at the point of intersection. So that leads into the perpendicular bisector theorem, and that states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that means is, looking at this picture, if CD is a perpendicular bisector of AB, then AC is equal to CB. So it's saying, like, not only is AD equivalent to DB or congruent, but the diagonal segments, or the hypotenuse legs, because if you notice it makes right triangles because it's a perpendicular bisector, the hypotenuse legs are congruent to one another. And then the converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So what does that mean? Well, this says if AE equals BE, so if the hypotenuse legs are congruent, and E lies on CD, so here's CD, the bisector, then it's a perpendicular bisector of AB. So that's what it says. Also, recall an angle bisector divides. This is clearly a typo. Divides an angle into two congruent angles. The angle bisector can be a line, segment, or ray. So that leads into this angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if ray BF bisects angle DBE and FD is perpendicular to BD, then FE is perpendicular to BE and DF equals FE. So here we have an angle bisector and we have these perpendicular lines. These lines DF and FE would be congruent, and then of course, since it was an angle bisector, these little angles here are congruent. And the converse of the angle bisector theorem states that if a point in the interior of an angle is equidistant from the sides of an angle, then it is on the bisector of an angle. So it's basically saying if you have these perpendicular lines here that are congruent to one another, then you can conclude that this was an angle bisector. So yeah, let's get into some examples. On these examples, I'm going to use the perpendicular bisector theorem to find the measure of each segment. So in example 1, AB is simply just 4.1 because that's what AD equals. And that's literally all there is to that one. You just know it for sure because BC is marked as congruent to CD. I suppose if they weren't marked as congruent, then you couldn't officially conclude that they're congruent. So WY is going to equal 3 because you have these marked as congruent, 9 and 9. So because these are congruent, then these must be congruent. So WY would be 3, WZ would be 6 if somebody ever asks you that. But yeah, that's pretty much all there is to say about that one. So in this one, you have QS congruent to ST. So that means you're going to set 2x plus 3 equal to 4x minus 7. Okay, to solve for x, I'm just going to minus 2x to the other side since 2x is smaller than 4x. That's going to give me 3 equal to 2x minus 7. From there, I'll get my constants on one side, so I'll add 7 to the other side. And so I'll get 10 equal to 2x. So divide both sides by 2, and you'll get x equal to 5. So with x equal to 5, it doesn't really matter which one you plug it back into since they said we're set equal to each other. But it does say RT, so I'm going to plug it into the expression for RT, which is 4x minus 7. So replacing x with 5 will give me 4 times 5 minus 7. 4 times 5 is 20. 20 minus 7 is 13. So that means both of these sides will be 13. And you can always do kind of a check too. What's 2 times 5? 10. What's 10 plus 3? 13. So yeah, They both equal 13, so you know you did it right. In this set of examples, I'm going to use the angle bisector theorem to find each measure. So in example 1, we're looking for xy. Because these are both marked as 41 degrees, then you know that this is 7, and that means xy will be 7. And that's it. In example 2, we're given that these are congruent. We're not given the measures, but that's not really that important, because if this is 37 and this is congruent and that's congruent, then that means this is 37. So the measure of JKL will also be 37 degrees. You got to pay attention to these and make sure it's not asking for the big angle. Like JKM would be 37 plus 37, which is 74 degrees. Every now and then you might get asked that, even though you look at this and you're like, oh, it's 37. But if you pay attention, the question might be asking you for the big angle, not the bisected angle. But in this case, it is clearly just asking for the bisected angle. JKL is just that little sliver right there. So in example 3, you have these angles marked as congruent, meaning this is an angle bisector. So that means you're going to set these two statements equal to each other. So I'm going to write 3x plus 5 equal to 6x minus 7 and solve for x. I got to get my x's on one side, so 3x is smaller than 6x, so I'll take it over there by minusing it. That'll give me 5 equal to 3x minus 7. So I got to get my constants now on the other side, so I'll add 7 to the other side. And adding 7 to the other side will give me 12 equal to 3x, which means I need to divide both sides by 3, and I'll get x equal to 4. So the question was asking us for SP, so I'm going to go ahead and plug in 4 for x into 6x minus 7. And remember, you should get the same answer if you were to plug it into the other one. So plugging it into 6x minus 7, 6 times 4 is 24. 24 minus 7 is 17. So that's what SP is going to equal. And then, like I said, you can always plug it into the other one to see if you did it right for sure. 3 times 4 is 12. 12 plus 5 is 17, giving you the same thing. So you know you did it right. So that's going to wrap it up for these notes. So thank you for watching. Stay tuned for part 2 of 5.1, and goodbye.